Well, this question here, no graph. So we start right in with a reading of the question. A stone is dropped from rest. All right, so we're going to take note right away is that V0 equals 0 to fall vertically through 16 meters in 2 seconds. So we've got our delta Z and we've got our time. Based on these measurements, what's the best estimate for the acceleration of free fall? So the first approach we might use, there's a number of ways we could go about this. But as a beginner, I recommend always using the steps that I'm giving you. And the first one is to always try to solve the problem using average velocity. So the average velocity in this case would be delta Z over delta T. Now we know delta Z is 16 and the time is 2, so that means the average velocity is 8 meters per second. So although we have the average velocity, that's still not the acceleration. We have a second, that's average velocity 1. Average velocity 2, we can use when the acceleration is constant, and it is. This is free fall with gravity. So v plus v0 over 2. Well, let's see. We know the average velocity is 8. We don't know the final velocity. The initial velocity is 0. Oh, so we can see that the final velocity is 16 meters per second. So we know the initial, we know the final. So that's step number 1. We still don't have the acceleration. Step number 2 is to use the average velocity table. And we usually use that when we know the acceleration. Now we have seen that we can use it to find the acceleration, but it's not the best way. And we go on to step 3, which is V equals AT plus V0. We know our final velocity is 16. Looking for our acceleration. The time is 2. And the initial velocity is 0. So the acceleration is 16 over 2, or 8 meters per second squared. Now, if we look, there's a choice here. Now, we expect that if this is on Earth, that the acceleration is 9.8 or 10. But we're not told in this case. And we're using our calculation for acceleration based on the data, not what we know or think it is. So we've got 8 meters per second. That is one of the choices. Now, we could check ourselves. We could bring in our fourth equation, which is z equals 1/2 at squared plus v0t plus zo. So we're looking for the z. In this case, we know it's 16. Well, actually, we just leave it blank. We'll ask, what is the z? What is the z? If the acceleration is 8, it's 2 seconds. Let's see, it's dropped from rest, so that's 0 and that's 0. Well, we get 1/2 of 8, which is 4, times 4 is 16. 16 meters. So if something accelerates with 8 meters per second squared for 2 seconds, that distance traveled will be 16 meters. So this is our check, and it looks like B is our answer. And of course, you can see if you put in any other number for the acceleration, you will not get 16 meters. So that's how we can both find and check our answer as being correct. Again, you don't have to know how to do any particular question, but just know what tools you have and apply all the tools in the order I gave you. Now, you can see with this check, you could have just launched right into this from the beginning. You could have started with this, and it would give you the answer much quicker. But you don't really have a check in that case. So you could have put in 2 and 16, and you would have found that the acceleration is 8. So you could have started here. But that's if you already know. Every problem can be solved if you go 1, 2, 3, 4.